Okay. Hello, everyone. I guess you can hear me and I guess you can see me because this room is very comfortable and cozy and I'm not that far. So, welcome. My name is Andrzej. I have a Twitter, I have a blog which is not very lively, and I work at eBay. And at first, a few things about me. Things I'm proud of, things I founded or organized or spent a lot of time are, well, first of all, I'm the leader of the Polish Java user group, even though I live in London. I'm the founder and organizer of GeekOn, a great Java conference happening in Poland, but not only right now. I'm the founder and organizer of Software Craftsmanship Kraków and founder and organizer of Kraków Hadoop user group. And why do I do a talk about Chef and, well, things like that? Because it sounded, well, scary or at least hair-raising. Well, if you've seen Inception, you'll recognize the picture immediately. Basically, I would call myself a developer that was curious to go deeper and deeper and deeper and see what happens beyond the normal things that you would do in a typical, I don't know, C++ development role or in a typical Java role. And I kept going deeper and try to see how do you deploy things and how do you organize servers, and it's a lot of fun and a lot of things to learn, so it keeps me busy. A few disclaimers, because of course you have to do them. First of all, my opinions are my own. It's not, well, eBay's opinion or anybody else's opinion. And please, if you have any questions, just raise your hand. Somebody will either give you the microphone or I'll try to listen and hear you and repeat the question. Can you raise your hands? Awesome. So we'll be happy with the questions. I know that there is an official hashtag for Devoxx UK, which is, well, Devoxx UK, and I chose the hashtag of chefing. Please tweet about the talk. Please tell me if you liked it, what you disliked. Your feedback is really, really important to me because, well, I want to know whether I'm doing a good job. And if you're already sleepy or not yet fully awake, a too long didn't read version. So first of all, there is life beyond Tomcat, or there are things happening below the JVM that one has to care about if they want to have a system running in prod, which you probably already know about, but to some people it comes as a surprise. I know, well, that's what life looks from my perspective. Then if you want to teach people, just start small and then teach them all one at a time. It's possible, by all means. Don't give up, It will happen one day, or you will just go somewhere else. And there is a very good book called Fearless Change by Linda Rising, and I'm not going to do too much advertising about this book because I know that there is a talk tomorrow by Linda and Regina in the morning in room number 3. So just by looking at this, I would recommend this one. If you're angry with your organization about some aspect and you'd like to change it, but you don't have no idea how, or you just would like to be more efficient at how you are changing people, they will probably give you at least some great hints, and it should be useful. So, a bit of background for the talk. How did it came to being? So, back in the beginning of last year, there is a new department in eBay. eBay used not to have any developers in London, nothing. And I'm saying eBay, not PayPal, because eBay and PayPal, even though they are the same company or the same mothership, as I call it, eBay organizationally is a separate entity. So there was a new department with a lot of new developers being hired, which happened in London, and our headquarters is in San Jose, which means we're kind of separate, kind of in the same org, but, well, really, the time zone and travel and the distance makes a difference. Because those were new developers, when you hire people for something new, you have the attitude of do the right thing and do it right. Because why would you accept something, well, less than optimal if you're building things from scratch? So as you can guess, our enthusiasm was just through the roof. We wanted to do things, we wanted to move fast, we wanted to, well, break things, at least have the next Facebook and other companies combined, at least. And then, of course, reality had to catch up with us, so a project happened. And in the team that I happened to be a tech lead on, well, we needed to run it, and we needed to run it relatively quickly, as in we got an application, well, part of the system that we were building was a third-party app, and we needed to run it somewhere. Of course, well, what do you do? At first, you can run it from your laptop, but shipping your laptop to a data center and, well, shipping a few of your laptops to a data center doesn't really scale. So what did we do? Well, simply put, we started to use Chef, orchestrated all the servers, life was colorful, there was world peace everywhere, and things were happy. Why Chef? Because I've used Puppet before, and I've used Chef before, and I found Chef much nicer to developers. So as I said, it was all amazing, all was beautiful, there were no problems at all, I'm just going to do marketing slides for the remaining time. Well, not really. The reality, as I said, was that we needed a production environment quickly. So what do you do when you need a production? Well, at first you need a few servers, and if you need servers, well, you need to find out what's available, and since we were new to eBay's infrastructure, the majority of software in eBay runs on something that is a platform as a service solution, so you need to package your software in a specific way, and then it gets run. But we had a third party that was, well, not approved to be run there, and we didn't want to explore, didn't have the time to explore. How should we package that so that it runs on our PaaS solution? So luckily, there was an EC2-like solution as well, which means we got a plain Linux box, well, a few of them, and we could play. So what do? Well, you log in, you bash things, well, bash even more, and then things start to run, and you're happy. But the thing is, well, things started to break, or there were a few people, so people had different ideas. I was spending probably the most time with that, and since I liked Chef, as I said before, I started using that. And, well, the Chef. Who has heard of Chef or used it, actually? Wow. So I'd say half of the room. For the other half, these are not the Chefs we are talking about. So, nope, not those guys. I'm talking about Chef with this logo, a creation of a company called Opscode. I guess they might have changed their name to Chef Inc. or something. First question is, why not Puppet? Why not something else? Why not Bash scripts? First, as I said, I like Chef. I've used Puppet before, and out of my personal preference, it's just easier for me to express myself in Chef because it's Ruby and I can write code and it gets executed in a sequence, and I find it really approachable, and it was all about the dev friendliness, to be frank. So the Chef thing, what does it look like? Why do I find it developer friendly, or why do I like it? Well, this is what Chef source code looks like. You can see a resource called package that will install a package called HA proxy. Well, you can probably figure out what it does without me reading the code, because it's a DSL, and I find it's very readable, very concise, and the basic things you could probably put in Bash or something else in a similar amount of characters, but the more complex it gets, well, the biggest Chef's advantages. So a thing like that, well, you've got resources, and so how do you live with Chef? You put resources into recipes, then you organize recipes into role, and then you apply roles to machines, which means it's, well, a pretty straightforward thing to do. And you've seen code, and yes, it's code. It's normal code. It's Ruby. It's a Ruby DSL, which for me is really easy to read, and because it's source code, nothing binary, it's also easy to version, easy to diff. You can well merge it. You can do all kinds of things that you would normally do with code. But also, well, it is a DSL, so it's not exactly what gets executed, which sometimes leads to problems. And well, the first problems that we got was, well, there is a lot of chef examples online, and there was a significant difference, or there is a significant difference between chef version 10 and 11. So it shouldn't be that blue, but still. People, when they were trying to use chef examples coming straight from the internet, sometimes got hit by it, which was the first problem that we had. Of course, the rule of thumb is don't trust everything you get from the internet, because it might be wrong, it might not apply. And some of the open source projects that are on GitHub are generally expected to work. With Chef, people usually open source what is their organization specific. For us, it was just their settings weren't really working sometimes, but people didn't know it. So there is a lot of Chef on GitHub. So there is a lot of Chef on GitHub. There is a lot of ready examples, ready recipes, cookbooks that you can download. With all this source code, you could probably think that I can just grab this, grab that, grab this, merge it all together, run it, and things will work. And sometimes they will, sometimes they won't. Because as I mentioned, version 10 versus version 11, or some assumptions, depending on other cookbooks, because cookbooks can depend on cookbooks, and as you know from Maven, probably already too well, it's going to lead to problems if things clash, and they did clash. And when you start discovering things like that, you come into a problem. And the problem works like this. But the code I got is from GitHub. Some people are using it. Sometimes the code that you're trying to use, it comes from, I don't know, Opscode contributed cookbooks, which means it should be good because the company behind Chef has its name in there. So why does it not work for us? Well, the answer was pretty simple and straightforward. Your infrastructure is your environment and your company specific. There is no general solution as how to make all the servers. If you would take one company's set of cookbooks or, well, Puppet or anything and try to apply it one-to-one into a different place, it wouldn't work. That's pretty easy to understand. This is the same with Chef, because Chef is configuration as code. Or sometimes people say, well, infrastructure as code. So if you'd like to learn Chef, well, it's quite easy to find tutorials online. And you are either capable of doing that, or you're capable of talking yourself out of any work and coming to more and more conferences not to do work. So coming back to Bash, well, some people say that it scales well, but if you've tried maintaining large Bash scripts, it's a pain. It's not as bad as Perl scripts, but it's difficult. You can also say that you should just hire more people, and yes, Protein scales very well. On average, 25 years to get a techie with the amount of experience that you require. I strongly believe in protein-based solutions, yes, of course. Well, not really, again. So we have this code. We have our servers expressed as code. We can apply configurations to thousands of servers because it's all automated. So we can automate all the things. And if we can automate things, we can automate our infrastructure, and which means it's awesome. It will be in the cloud. Well, all changes will automatically populate because, well, if anything like this happens for us, well, the infrastructure bringing up the server will happen in no time. All changes will automatically be populated, and you'll be able to reconstruct all the things really quickly without any problems. If you add some smart monitoring, it will even happen, well, almost by itself with just generating a few alerts that your smart environment did things. But again, in my situation, remember, we were developers trying to do or doing infrastructure. What is the problem with developers doing infrastructure? Well, there is a lot of problems with that. Well, maybe not problems, but caveats. First of all, developers have a different mindset. For us, making changes to things, breaking things, is the daily bread. That's what I do because I want to bend things or change them or twist them and to get into a certain direction. Typical operations want to keep things running. Change equals risk, therefore you either minimize or you try to test them before. So we had a few problems. We had, well, quite a lot of them actually. What could possibly go wrong in terms of our situation? So new developers, really good people, but trying to do infrastructure. Well, first of all, it wasn't easy. It still isn't easy because we are still using the Chef cookbooks that we've created, we started to create and we maintain them. Reality, of course, had to kick in. As I started with joking around Tomcat, yes, there is life beyond Tomcat, and that was a huge surprise to some of the people. Some of us are used to deploying war files to places, and then somebody else takes care of that. And sometimes it's okay. In certain circumstances, I would be, well, happiest doing that. In certain circumstances, I would not. The situation we were in didn't allow for this, which means we had to learn or we had to explore what happens in other situations. Also, if you're doing Java, part of the promise that the JVM gives you is that your operating system, well, you don't have to know your OS specific things. You don't have to know which packages you have to get. You don't have to know, well, all the things. Because Java gives you an abstraction, and because, well, there is a well-defined deployment model, so you just get a server, you deploy your application archive into there, and all will work. And there is some magic going to happen so that you can see my slides. And, well, who uses Linux in here? Who uses Ubuntu? And who doesn't use Ubuntu? Yeah, so you know that there are differences between Linux flavors. Those are some of the problems that we had to go through. Luckily, in eBay we standardized right now on Ubuntu server, which was quite easy because almost everybody uses Ubuntu on their desktop, which meant we already were pretty familiar with the server environment that we had to, because you knew where the configuration files would be, you knew where, well, what to change, how to change things, and how to orchestrate them. Also, it meant that people could run the tests on their desktops. Most of the people could, because some of them were running Windows. What did we do about people running Windows? Well, exactly nothing. We are not going to force them onto using a different operating system, because if they prefer to run Windows and do coding in there, well, I'm okay with that. It's just our Chef infrastructure has never been tested. We never really tried to make it runnable on Windows. It maybe it does, but basically we were not worried. Maybe we'll get something to display.
Can I ask a question?
Sure. We have plenty of time. If you have questions, well, just wave your hands. We can buy ourselves some time.
So you mentioned about developers running Ubuntu on their machines. So you use the same chef recipes that were used for creating your production environment to create the development environment as well?
So you're asking if we use the same chef recipes to configure development machines as we would configure production. No, we didn't do it directly, because at least my approach is that my workstation will have a lot of quirks happening inside it. So it will not be configured the same way, and I don't want an Apache running on my machine. I don't want whatever, HA proxy and Nginx or all those kinds of things. I don't want a Nagios that would report to things, or I don't want a Ganglia monitor, because why would I? So we used VMs our desktops luckily are pretty powerful, which means Vagrant and running machines and being able to spin up a machine in a matter of a few minutes. So we would run it in the software that we would try to see how it actually works on a VM. Because again, why spoil your machine? Also, then you could do the same on a Mac because you would be based on the same VM image and it would work. So, as I said, in Java, servers just happen, which is sometimes okay, sometimes not. It depends on your approach. In our approach, that wasn't enough. So, what happened? We needed buy-in. And by buy-in, I mean people needed to start to use the tool, which for me, as the biggest culprit behind the whole idea, was that form needed to follow functions. So we needed to keep things simple. And you know that simplicity is good, but if you introduce yet another tool into an organization, as it says, it becomes yet another tool. And because this is a Java-centric environment, well, there was a very tiny problem. And the problem is exactly like that. What do you mean this code is in Ruby? Why is it a Ruby DSL? So I will not be able to use IntelliJ? Well, luckily, people that we hired were very smart, or are very smart. Ruby wasn't a problem at all. At first, we were afraid that Ruby would be a problem, but Chef is much easier. We found Chef much easier to grasp than, for example, Rails. If you've done any Rails beyond the basics, sometimes it gets funny. You can get very far with simple iteration and getting variables. This is exactly what we did. So our code was simple, but people didn't have any problems, especially if people knew Python or Scala or other languages. They know how they will catch those structures really quickly, and they did catch those structures really quickly. That wasn't a problem. Polyglots for us was the solution that just happened, and it also happened to work. Another big decision that we have to make was, should we run Chef in a server mode or a solo mode? So what is server mode and what is solo mode? Basically, server means there is a Chef server that orchestrates other machines, and it all basically just happens. You just upload make changes, upload them to the server, they will be populated to the machines. Or you can use Chef Solo, in which you take the current snapshot of all your code and apply it to a machine on a one-by-one basis. Or if you're running a terminal multiplexer, you can do it to multiple machines at once, but still, it's basically a one-off action. We went with Chef Solo. Why not Chef Server? Basically, this is why. We had a bunch of people doing Chef who were not familiar with Chef. At first, there was only one person comfortable with the tool, and that was me, and I didn't want, well, it would be irresponsible to build in a huge possibility of failure, so that, well, if somebody made a typo or started to put strange things in strange places, all servers would be, well, at least polluted, if not broken. So changes wouldn't automatically propagate, which means people's machines were not broken by themselves. You had to, well, pull in the changes, well, or you could always revert, or you knew what was happening. And that was, in the beginning, that was a good decision. Right now, we are starting to get hurt by it, so we're starting to think about going Chef server, but as of, well, before there was no point, and still, if you have people that have not used it and if people that are trying to learn it, I would wholeheartedly recommend going Chef Solo in the beginning. Chef server is a good idea after you understand more or less what happens. Something we had to do was code reviews, because Chef code, anybody can type anything. Running tests is not exactly, well, you can do TDD in Chef, you can write tests, but it's not going to be exactly as good as in Java. You don't get you can get lint tools for it, but there is nothing like Sonar that will tell you that your complexity is growing. Somebody has to read it. What we used was a tool done by Konrad called Review Kiwi that would email you all the change sets. It's a pretty straightforward to use thing that just gives you, instead of a GitHub notification that somebody pushed something into this repository, this actually gives you the diff that happened. I found it extremely useful and extremely easy to follow. I liked it for this role, fit its role perfectly. So I, again, recommend it. Biggest problem about Chef. You've seen the DSL. It speaks about doing some things. There is something in Chef that I call dual execution. It's not the correct term. You will probably not find it online if you type dual execution like this. Frankly, I have no idea what you will find if you type in dual execution. The way Chef works is, in a very simplistic way, it gets all the code, tries to instantiate. It tries to instantiate the objects, the resources, to create an in-memory model of what should be applied to a machine, and then applies it to the machine. And you can get parameters from two places. You can get parameters that describe this very machine, this VM or the system that you're running on, or you can apply this to a machine that you have started to run on, or the Chef server or your property files. And different resources run differently. This led to an infinite source of problems, which means people didn't know which parameter or what happened when. Which also meant when you were doing bash, if you were testing on a local machine, and that's probably coming back to the question about why didn't we configure our developer boxes with Chef? Changes were. You could easily see what changes or where parameters came from if you were doing that to a VM, because a VM was significantly different to your dev box, because, for example, your home directory didn't contain certain usernames, which means you could read what happens. That was our biggest problem. A solution to it we haven't found. It's just getting used to how Chef works. People are a problem, unfortunately, and we have not found a solution for that. And by people, I mean politics. So, because eBay is a big organization and there are different solutions available, different ways of running your applications, different people prefer different things, as obvious. There is a platform team that does the platform, the PaaS solution, and they, of course, promote their solution as the one that most of eBay runs on. And yes, that's perfectly valid. If you want to run somewhere else, we had to talk and fight quite a lot not to use the defaults. From my point of view, it was extremely inefficient. We lost a lot of time doing talking and calls with San Jose, which is plus 8 hours from here. What could we have done differently? Just believe that what we're doing is correct and just do things instead of trying to get approvals for absolutely everything, because that didn't serve any purpose. People still kept saying things. Another aspect of politics was people in London office. Some of them preferred us to use the platform as a service solution. Some of them preferred us to use a different stack. But those stories you know from your own companies, I guess. If you want to introduce a new library, if it comes as a problem, or if you want to introduce Scala, it is a pain. You have to somehow, use pixie dust, or have a pint with them. Somehow get some people to accept your change, or just quietly do it and then present with facts already taken place. But we are running with this, and it's in production. If you want to change it or rewrite it, feel free. But this is running. Partly, we did it partly this way. It worked, but it was a pain. And politics, unfortunately, was still remains a significant issue at the office. There was a single point of problems. or single limitation to the scalability of doing Chef in eBay. And that was, well, me. Because at first I was the only person knowledgeable about the tool. I was the one introducing it to people, and well, what I did was trying to show it to people so that they would know how things work, why they work. Well, basically teach. At first, I was trying to review all the changes. In the end, I was reviewing all the changes, which meant that people relied on me being there. That was probably a very bad decision. Well, that was a very bad decision because I don't scale that well. Because I also want to sleep, and if you spend a lot of time reviewing changes and going through others people's code, you don't have time to do anything else, or you get less time to do anything else. And well, some people might also get to a point to, well, if I'm a developer and you're a developer and I'm a Java person, I was hired here to do Java, and you've been hired here to do Java, because we all just learned Chef. Our chefs are, well, the same because, well, we are the same kind of people, so our code is the same quality. Well, reality is different, but some people still went with an approach like this. At first, I tried to fight it, didn't work, only created, well, problems and angry faces. No teeth lost their places, luckily. My answer would be let people do mistakes. If people make mistakes, things will break, and they will discover sooner or later, usually sooner, that the approach that they are taking is not necessarily the optimal one, which also meant that, well, what this guy was saying actually makes sense, and maybe next time we should listen to them. It might be a small thing. Ideally, if you can let somebody learn on the small things, it's good, but some people really want to take on really big things, and sometimes they are very stubborn in this approach, and to such people, you can either wait, go on holiday, or use a mind trick. The mind trick that I used in the office was, well, basically something that the book mentioned in the beginning calls do food. I would narrow it down to use food that contains sugar, because sugar produces endorphins. If you're talking with somebody and if you bring them sugary things and they eat those things and your brain knows, your mind know that you're being manipulated, but it actually works. It will make people think that whatever the conversation with you will bring sugar, which means it will bring happiness. So I should want to work with you. And if that was an extremely useful thing to do, I had to resort to it a few times, and I highly recommend bringing a bunch of, well, cupcakes or muffins or whatever people at your place like. It works. Half an hour, a muffin later, yeah, no problems. It's all great. You're great. I'm great. We'll all have fun, and well, we'll do it your way, sure, because you're cool, because you brought in the cakes, and people were smiling. I also mentioned Vagrant. Vagrant is awesome, and I cannot tell you how awesome Vagrant is for trying and running Chef, especially learning it. It's simply amazing. Why is it amazing? This is part of a Vagrant file, so a file that Vagrant interprets to know what more or less it should instantiate. Well, not more or less, exactly what it should instantiate and how. And there is a Chef solo plugin to it. So you can tell your Vagrant file where your Chef cookbooks are, which also means that you can tell it what recipes and what roles and what properties it has to have when instantiating the virtual machine, which means you can basically do TDD or have short development loops with a tool that is automated and requires a single command, which is extremely important because if you're not used to doing system stuff, it's something that you have to learn. If you've never tried Vagrant, please do. If that's the only takeaway that you will have from my talk today, I will be really happy. So, moving on. Have you heard of the law of large numbers? Okay. Anyway, the law says that the more or less, of course, because I'm not fully proficient in maths in English, the more time you run an experiment, the closer the average observed value will get to the expected. And you probably know that servers break. There is, what, 3%, a 3% chance that server will break. Well, who has had a hard drive failure? So, oh, 7 people in the room. So if we would get, well, many rooms like this, you would get 100 hard drive failures. And now if you imagine an infrastructure, well, you have a lot of servers, well, many, hundreds. It will mean that many servers break a lot. Which brings us to a Phoenix. And I'm not talking the Eurovision kind of Phoenix, so there will be no sausages or wursts or anything. Something that's called the Phoenix pattern. Otherwise called, well, the disposable servers, but I think Phoenix pattern sounds cooler. The idea is pretty simple. You don't fix boxes, you bake new. Why? Why would you not fix a box? It's a single box, I know what to do, I'll just SSH into that and fix a few things. First of all, it might just work. You might just be able to SSH and actually fix the thing that wasn't working. There's also a chance that it will not, because you might discover that, for example, your libraries got corrupted or your hard drive went crazy. Put in a more formal terms, changing state from unknown using a known transformation will probably result in an unknown state, and you want your systems to be in a known state. How do you get around it? How do you tell people not to SSH into boxes, just to fix this tiny thing, and then fix this tiny thing, and then fix this tiny thing, and then probably also forgetting to go back to the Chef cookbooks that we started with, and reapply this change to the cookbook, so new servers don't have this error, well, built in. You break, well, being able to log in. You can disable, well, the default login mechanism or change it significantly. So there is still an emergency way to log in, but if normally you cannot, because it's broken, people will actually keep spinning up new machines because it's easier. It worked. It was yet another mind trick that had to be used, but it was worth it. It was a good solution to the problem we were having. Do you need it? If you try going Chef and people like SSHing into boxes, probably you will. So I've given you, well, this awesome story about using Chef, orchestrating, configuring servers. So awesome. So the question comes, how did we deploy? Well, you probably think that we did use Chef for that, and the reality is we didn't. Because Chef is a system configuration tool. Chef is for getting a box that is able to run your application, but we don't, I'm very much against using Chef to actually put WAR files onto things or running Chef continuously to deploy things. I believe there are different tools better at it. So we prefer using different tools. Mostly we use Jenkins that was just pushing the last running version, mostly because production was slightly different. But it worked pretty well. Just having Chef as something that configures the box means you can test run your box setup, and then you can run deploys separately, which means you get 2 loops for development, which means, well, you can scale better. Something really useful is to have a base role, so something that all configuration, well, a giant superclass. Why was it extremely useful? Because then, when we talked to the ops people, when we told them that we are using Chef, they were very happy to find out about it, and they could modify things inside here. So they could add a monitoring solution of their preference, or they could change monitoring, well, configuration or some other logging, or add Tmax or other things without breaking anybody's work. And this base role, because it's a base role, it was included in all the servers, it would be populated to all of them, which was pretty awesome, worked, highly recommended. So, question becomes, what do we do now? Because, well, we have our dev environment orchestrated. There are political fights that prefer us to use a different solution. How can we grow what we already have? It turned out that our QA or QE department came to the rescue, or maybe not to the rescue, because those are not manual testers. They are not clicky testers. These are testers who actually write code that will be repeatedly executed. And because mobile thing is a very big thing, well, mobile is a very big thing for us. We need to automate testing mobile applications, testing things on iOS, testing things on Android. Chef is perfect for orchestrating that. Of course, it's a bit funny to orchestrate OS X boxes, and I have no idea if it's even how orchestrating Windows boxes work. But our current project is to automate a Mac cluster, to have iOS driver enable an automated way of testing web applications on an iPhone or other things, or something like this, which is something I've never thought of when we started, but this means that the journey will continue and we'll get somewhere. I have no idea where, but it's also a good sign that if what we were trying to change, it actually stuck and people like it, and people see this as the correct way of doing things. Which means now we can go to the Q&A. Do you have any questions? I see Steve having a question.
Quick question. So, if you went back in time when you started this, would you still use Chef, or would you have gone some other way?
So the question is, if I could back in time and I could change all my decisions, and would I still use Chef? As of today, I would say yes. It seemed like a very good tool for the job, especially being able to write code in Ruby was very, very helpful, because people could write loops the way they would expect. They could write ifs the way they would expect, which was, great, because it meant developers could understand what's actually happening, and they could debug things, and they could work with code they understand. We didn't go Puppet, and that seems to be a good decision. We tried, looking at Puppet in a small group of people, but if you know how Puppet works, it's not a Ruby DSL, which means it's just harder to grasp. Anybody else? Sure.
You mentioned about platform as a service solution that was being proposed.
Uh-huh.
There were various reasons why you did not select that service. Is there anything that you can share? Were there technical reasons or political reasons why platform as a service was not appropriate?
So platform as a service, why didn't we use it? What were the reasons behind this decision? My short answer is, my answer is we needed to get up and running quickly, and we had a third-party application that we needed as a part of our solution, and we didn't want to investigate all of the hooks, all of the things that all of the formats that the past solution had. So we knew how to do it relatively quickly using an infrastructure as a service. So we did that because it was just easier for us. About politics and other things, probably let's talk later after the talk. There is a question in the back.
I'm quite new to Chef and Puppet and how deployment works. But what we do in our company is we create like an image of a server and then deploy that. I'm just wondering what are the advantages and disadvantages of like creating images. For example, in Amazon, there's an AMI image, and you can recreate a new server based on this image.
Well, so the question is, in the company that, I don't know your name.
It's Nira.
I'm afraid to repeat that. But why not create images, or why create images? First of all, because we want to be able to develop on our own machines, and we want to have production and QA and all the stages in between be similar. And if the lowest common thing was that it's a Linux box with a console access, so you can automate things from this level. which for us meant that if we created an image for the dev boxes, those images would be different than the images for the cloud solution we were using, which would be not really solving our problem. Another thing, well, doing images while in Amazon, I can imagine it might make sense under certain circumstances, means that, well, you freeze certain bits of config, and, well, after you have an image, do you want to apply changes, or do you want to keep redoing those, keep reconfiguring them? What do you want to do with them? We believed in having boxes from scratch all the time to eliminate errors. Also to make sure that it always works, because yes, you can get to a situation in which if you take image A and then apply current changes, it will work. But if you take an image B and apply all the current changes, it will not. Which means it gets more complex if somebody would try to. We believe in having a stable master, or, well, a stable state of code always, which means by forcing everybody to run it frequently and running infrequently, we test it frequently, which means it mostly runs. And I think we can, well, keep discussing this more later as well. So the question is, do we use Chef only to configure things, or do we use other things as well? To us, we take an image that's already sitting there, which is a plain Ubuntu installed and already uploaded, and then apply all the chefs, which means we don't use any other tool. There is a hand in the back.
The question is, did you ever encounter problems from operational people when you were convincing them to actually use the Phoenix pattern?
Did we encounter problems with ops when we were using the Phoenix pattern? Of course. But also they're surprised that we actually are using Chef, and we are able to get ourselves up and running quickly and more or less properly, meant that the discussions were much easier to go through. And, well, frankly, Phoenix pattern, it's one of the approaches. We used it because we had people, as I said, we had people that were not familiar with Chef. So the more times each time you execute it, you had each time you made changes, you had a huge potential at first for damaging things. So you wanted to execute it as a whole. So you wanted to catch errors as quickly as possible. In production, it was relatively safe. So, moving on, summary. The most important point is, well, people are complicated, computers are easy. Most of the problems I mentioned were about people and people's attitudes, not about technical solutions, unfortunately. If you're doing something, if you want to change things, well, keep it simple, do those things, then comes the magic pixie dust, and then you can profit. And, well, thank you. That's all.